Hello everyone. In this session, let us look into a numerical that is related to Huffman coding. In the previous session, we have seen what is the purpose of compression in image processing as well as different techniques in under compression. One of the famous technique under compression is Huffman coding, wherein we are allocating bits to each and every intensity values based on the frequency of appearance of this particular pixel in the image. So here is a numerical problem wherein an image is given of size 10 cross 10, and it is also mentioned that it is a 5-bit image. So we need to prove that upon applying Huffman coding, the space required or the transmission rate required for transmitting this image is reduced when compared to transmitting the image without compressing the image. So here in this case we have a 10 cross 10 image of 5 bits each. So the total space required would be 10 into 10, that is 100 pixels will be there, and each pixel having 5-bit value, it will sum up to 500 pixels or 500 bits. So we'll sorry, not 500 pixels, it is 500 bits. So we will see after applying Huffman coding how is the number of bits getting reduced. Apart from the size of the image and the bit representation for each image, we also have the intensity values given, or this can be also called as a symbols. Symbols or the intensity values are given here. So it is represented as different symbols from A1 to A6, and the frequency associated with each symbol is given here. So it means that A1 is a pixel that is appearing 10 times in an image. A2 is a pixel that is appearing 40 times in this image. A3 is a pixel that is appearing 10 times, and A4 is a pixel that is appearing again 10 times. And did I go wrong? A3 is a pixel that is appearing 6 times, and A4 is a pixel that is appearing 10 times. A5 is a pixel that is appearing 4 times in the image. A6 is a pixel that is appearing 30 times in the image. Now let us find the probability of occurrence of each pixel or each intensity value. So let us write probability of occurrence as we have it in the question. It is given as it is a 10 cross 10 image. So the number of pixels available for this image is 10 into 10, that is 100. So probability of occurrence of this particular intensity will be 10 by 100, which is equal to 0.1, whereas this is 40 by 100, which is 0.4. This comes up to 6 by 100, that is 0.06, equal to 10 by 100, 0.1, and 4 by 100. Sorry. 4 by 100, we get 0.04, and this is 30 by 100, we get 0.3. Now the next step is to arrange these probabilities in descending order. So let us sort it. We'll say sorted probability. So we have the highest probability in this set of pixels is 0.4. So let me write 0.4 first and look into it. 0.4 is associated with the intensity value A2. So let me write A2 here. This is the intensity value. Let me type a heading, intensity value. Again, it is sorted. And then we have, after 0.4, we have 0.3 is the next intensity. So 0.3 is associated with A6. So I have A6 here. And then next highest is 0.1. Let us start from beginning. So it is 0.1 here associated with A1. So associated with A1. I have one more 0.1, that is this, which is associated with A4. So I have the next one associated with A4. And then we have 0.06. So 0.06, which is associated with A3. And then 0.04, which is of pixel A5. A5. Now we have the intensity and probabilities sorted in sorted order, decreasing order. The next step is to, according to Huffman coding, it says that add those intensities, probabilities of the intensity which are lowest in the set. So here I have 0.06 and 0.04. So let us add these. Let me highlight it with a color. So here I have 0.06 plus 0.04 is nothing but 0.1. So I have 0.1. Let me rewrite the remaining intensities as it is. So I have 0.3 and 0.4. So let me call this as unsorted for the time being, because after addition I get a new value. It is an unsorted. It may be bigger or maybe less than the remaining values. So let me sort it. So I, in this case though, I get both sorted and unsorted as a same set of numbers. Okay, so now you can see there are there are three 0.1s, but the 0.1 that you received or you got it after adding these two values, these two probabilities of the intensity, is this part. So let us highlight it with the same color. Okay, so this means that this 0.1, the probability sorted in the sorted probability, this 0.1 is obtained by adding 0.06 and 0.04. Now I have the least values in the sorted list is zero point 0.1 and 0.1, these two. So let us give a border to it just to identify it from the remaining elements. So these are the first time addition. Okay, now adding 0.1 and 0.1, you get 0.2. Let us write the remaining values as it is. I have 0.1, 0.3 here and 0.4 here. Okay, let me call this as unsorted. Okay, now you could see 0.2 you obtained from adding 0.1 and 0.1. These are the two numbers we added, right? Now you are getting 0.2 from adding 0.1 and 0.1. Now we have to place it in a sorted order. So let me sort it. I have 0.4 initially, then I have 0.3, then I have 0.2 and then 0.1. So 0.1. Now this 0.2 is shifted here. So let me give a highlight to it, indicating that this 0.2 is shifted here. Now it is in sorted order. I should add the last two numbers or last two intensity values. So let us put it in a block. So adding these two, I get 0.3. Let's rewrite the remaining as it is. So I have 0.3 and then I have 0.4 here. Let me call it as unsorted for the time being. Okay, so addition of this, we got 0.3. So let us highlight it. Okay, so here there are two 0.3s. We should understand that this 0.3 is the sum of 0.2 and 0.1. So I am highlighting that part. Now if you see, we need to sort it. So let me sort it 0.4, 0.3 and 0.3. And make sure this 0.3 is an addition of obtained by adding the least two intensity values. Okay, now I need to add these two. So let me box it. So I have 0.6 here and then I'll retain the original one and I'll call this unsorted. Let us sort it. So what happens? This is then sum of the least two probability of the intensities. Now once sorted, you will get 0.6 and then finally 0.4 here. But look into this 0.6 is shifted here. So let me highlight this too. Okay, now we finished summing it up. When you get at the end, when you get two intensity value, that is two values for the probability of the intensity, you may stop. Now our next task is to assign the bit values and backtrack. So in this case, you may assign first value, that is the highest value of the intensity, as 0 and the next value as 1. So initially what do? We assign first value as 0 and the next value as 1. Now we will backtrack. We know that this 0.6 is obtained by adding 0.3 and 0.3. So we need to assign values to this as well as to this. Okay. So how do we assign values to this? It is a bit representation. So we will assign the least significant bit for 0.03 as 0 and 1, as we did it in the previous case. That is, for 0.6 and 0.4 we assigned it as 0 and 1. Even here, least significant bit we will assign as 0 and 1. Now 0.3 and 0.3 summed up to 0.6. The bit value of 0.6 is 0. So we will precede this least significant bit with the bit value of 0.6. Okay. So we get 0, 0 and 0, 1 as the bit values of 0.3 and 0.3. Now we will go back and check. Next summation is 0.2 and 0.1. So we need to assign bit value to this. So first step is assign least significant bit. So let us assign the least significant bit as 0 and 1. So we have assigned the least significant bit as 0 and 1. Now we need to proceed. We need to write those bits preceding to the least significant bit as the bit of the summation of 0.2 and 0.1. Sum of 0.2 and 0.1 is 0.3, highlighted in yellow. Please note carefully. There are two 0.3s and two bit values was 0.3. You will pick that bit value of 0.3 which is highlighted, which is the sum of 0.2 and 0.1. So here it is 0, 1. So let me replace it with 0, 1 and even here with 0, 1. So the new bit value for 0.1 and 0.2 is 0.2 is 0, 1, 0 and 0.1 is 0, 1, 1. Now the next summation is 0.1 and another 0.1. So let us try assigning bit values to this. First step is to assign the least significant bit as 0 for the first term and 1 for the second term. Now we should see what is the sum of this. Sum of this is 0.2, highlighted in yellow color. That is, even though it is moving here, what is the bit value of that? 0, 1, 0. So precede it with 0, 1, 0. Precede this also with 0, 1, 0. So I've got a bit value for 0.1 and 0.1 here. Even though these frequencies are same, it is associated with different pixels. So this one has value 0, 1, 0, 0. This has value 0, 1, 0, 1. Now how did you get this 0, 1? We got it by adding these two values, that is 0.06 and 0.04. So let us assign the least significant bit to this as 0 and 1. Now we need to precede it with some bit. How do we choose that? 0.06 and 0.04 summed up to 0.1 and the bit value of 0.1, the one that is highlighted in yellow color, is 0101. So we need to precede this with 0101. Similarly, this also with 0101. Now you could see the intensity values for the bit values for A3 and A5. We have got it as 01010 and 01011. We need to assign bit values for these pixels also, that is A2, A6, A1, A4 also. So let us try how to get bit value for 0.4. Okay, so we will see, I'll just try to notate it through an arrow mark so that you can easily trace it. This 04 is traveling this side, right? Okay, so we need to identify what is a bit value. Second, I'll just copy this. So let us find the root of this. Okay, I have it here and then it is here. Again we have it 0.4 here, 0.4 here. We have not received any bit value till now. Okay, now we have 0.4, and then I have the 0.4 here, and I know what is the bit value of 0.4. 0.4 is 1. So here this has a bit value 1. I can highlight it if you're not able to uh, identify it. We will highlight it with a color. Might be a blue color I'll choose. So this is the path of this particular, to identify this bit, this is the path. Hope you could understand this. From where I see, what is that I need to do is I need to find the bit value for A2, which has frequency of A2 has a frequency of 40. It's appearing 40 times. So the probability of appearance of this particular pixel is 0.4. I need to assign a particular bit value to this 0.4. So we need to trace and check what is the bit value for this particular pixel, that is A2. So here is the tracing and I get the bit value of 4.4 is 1. So I've given this. Now similarly, let us trace for 0.3. So 0.3 is here. Let us give another color to it. Okay. See, 0.3 moved here. This same 0.3 is moving here. It's moving here. It's moving here. It is here and it is here. Sorry. Now let us trace for to identify the value of 0.3. So we can see 0.3, it's from here. Let us trace it. Now you could see the value of 0.3 is 00. Please kindly make a note of it. This 0.3 is a summation of these two. So this 0.3 is different from this value that is being traversed or moved. So here the value of 0.3 is 00. Hence this probability frequency, or this particular pixel called A6 will have a bit value 00. Now let us trace for 0.1. So this 0.1 is from here to here. I have a movement, it is not moved anywhere else, and we have it here, and then it is in this during sorting. You could see that this 0.1 is moved from this position to this position, because 0.2 is greater than 0.1 and 0.2 occupies the position of 0.1 and 0.1 comes here, and we have the bit value here. It is 0, 1, 1. So let us assign the bit value to this as 0, 1, 1. Next we have another 0.1 here. So let us trace it from here to here, and upon sorting it is still here and the value is 0, 1, 0, 0. So this will have a value 0, 1, 0, 0. Now you could see all the intensity or the pixels have a bit value associated with it. A1 has a bit value 0, 1, 1. A2 has a bit value 1. A3 has a bit value 0, 1, 0, 1, 0. A4 has a bit value 0, 1, 0, 0. A5 has a bit value 0, 1, 0, 1, 1, and A6 has a bit value 0, 0. Having identified the bit values for each of the pixel, let us check what is the average length of the code now. So I can write L average, length of the code L average equal to the probability of frequency of first pixel, that is A2 is 0.4, and it takes 1 bit, right? So I'll write it as 0.4 takes 1 bit plus the next one, that is 0.3, takes 2 bits plus 0.1 here takes again 3 bits. So we can write 0.1 into 3 plus next one is 0.1 takes 1, 2, 3, 4. That is this particular pixel. A4 pixel takes, which has a frequency, probability frequency of 0.1. A4 takes 0, 1, 0, 0. That is 4 bits. So I can say 0.1 into 4 plus 0.06 multiplied by 1, 2, 3, 4, 5 bits plus 0.04 multiplied by again 5 bits. This will sum up to 2.2 bits. So we can say the average length of the code will be 2.2 bits per each symbol or per pixel. All right. Now, if this was not done, if we had not compressed, uh, if we have not applied the Huffman coding, according to our question, it was given that the total number of pixels in the image is 10 cross 10. It's a 10 cross 10 image. Each pixel is taking 5 bit of space. So the total number would be total number of bits transmitted without compression. Compression would be that would be equal to 10 multiplied by 10 into 5. So this will sum up to 500. Now let us also look into what is the total number of bits transmitted with compression. Sorry. Okay. So I'll write here total number of bits transmitted after compression. After compression would be, it would be 10 multiplied by 10 into 2.2, because we have said the average L average length of average length of code is 2.2. So this would be 220 bits. So you can see the difference here. If it is not compressed, without compression, it would be 500 bits, whereas after compression, or if you apply Huffman coding, the total number of bits that will be transmitted is 220 bits. So here itself you can see how much you have saved by by applying Huffman coding. Let us look into that, how much will be saving. So how much, I'll just write how much is saved. That would be equal to 10 into 10 into 5. That is the total number of bits transmitted without compression minus 10 into 10 into 2.2 after compression divided by, so I'll divide this whole divided by 10 into 10 into 5. So this will give me 0.56, or I can even say it is 56%. So 56% of space is saved, or transmission rate is saved by converting it into compressing it using Huffman coding. Thank you, and that's all for this session. I'll be back again with a new video on image processing. Kindly subscribe to the channel to get updated on various techniques in image processing.